As we've done previously, we'll start with the Allegro sample 3C source code and modify it. Our goal for this tutorial is to put together what we've learned so far about graphics programming, arrays, and structures to create a simple game. Before we move forward, let's split our code into two source files. This will help us organize our code better, since it will quickly bloat as more lines of code are added, and soon we'd have a single huge file on our hands. We don't want this, so we'll quickly start spreading it out into two different files. Let's create a new project and add a source file called main.cpp to it. Copy and paste the Allegro sample 3C code into this new file. Don't forget to change the project properties to support an Allegro program. Quickly build the program to see if it runs. With that done, create a second source file called gameobject.cpp. Take the gameObject structure and drawObject function and put them in this file. Now if you compile, you'll get some errors on both source files. The problem is that main.cpp is now missing code relating to gameObject, so the compiler is getting confused. And also, gameObject.cpp hasn't got any includes. To fix these issues, we'll first copy the include lines from main.cpp and paste them into gameObject.cpp. It doesn't need all of these files, but there's no harm in adding some extra ones. In general, every source file needs to include the header files for any functions and structures it uses. As such, main.cpp needs to know what gameObject and drawObject are. So we'll create a new header file for the project, which we'll call gameObject.h. In this header file, we'll want to put a definition of our gameObject, as well as a function prototype for drawObject. Remember that a prototype is simply a summary of what the function does, so that the compiler knows what it can do. You can only define structures and functions once. A function prototype is not the definition of the function. It's the declaration of the function. It's only showing that this function exists somewhere else. Okay, we've got quite a few includes here. Perhaps we can simplify things further by just grabbing all of them and putting them in their own header file. Then we only need to include our master header. We'll move all the included lines to a new header which we'll call main.h, and then refer only to that one. This will make things much easier. The order of includes is very important, so just like anything else that's done multiple times throughout our program, we want it to only be written once. That way, if we need to change anything, we don't need to go poking around the whole program. Remember that angle brackets indicate that the files can be found in the standard include folder, whereas double quotes indicate that the files might be found in the project folder, and if not there, then maybe they're in the standard folder. So now we have a single master header. We only need to include this one at the top of any CPP file, which makes it much more convenient for us. To summarize the process of splitting a project such as this into multiple source files, first, we move some of the code into a new file. Then we create a header file with the same name and move all the structures to it, adding prototypes for any functions we're bringing along. Then in every source file, you can include all header files necessary for that code to function. Alternatively, you can make a main.h file and move all include lines to that, then include only that header file in all CPP files. If you are creating multiple header files, pay close attention to the order that they're included. Any file that is using another has to be included after it. Also, files can be named anything you like, but it's wise to follow a consistent pattern to keep the project organized. Naming a related header file after its source file is typically a good idea. So GameObject.h goes with GameObject.cpp. In this tutorial, the game we'll be making will consist of a few elements: a player, a few enemies that have to be avoided, and a series of objects that have to be collected for points. To continue, we'll need a few images. We've provided some with this tutorial, but feel free to use your own images if you so desire. Just make sure they're in the project folder. So to begin, we'll want to create a few objects in the initialization section of main. We should also comment out this code for rectangle, since the player will be a game object now. We'll need to comment out any references to the rectangle as we go. We'll create game objects for the player, several enemies, and points. The enemies and points can be arrays to simplify managing them later in the program. We'll use a label for each of the array sizes. That way we can easily change the number of enemies and points in the game. We'll initialize any array members inside a loop, so we can be sure every one of them gets set up. The loop will run from 0 to the number of elements in the array, using our handy label. We also want our objects to have randomized locations when they're generated, so we'll use the rand function to initialize our object's x and y coordinates. Remember that the value returned by rand will range from 0 to anything in the tens of thousands. We can use the modulus operator to bring that down to a reasonable set of numbers. For x, we can use rand modulus 600, say, which should confine it to the width of the screen. For y, we can use 400 for the same effect. Remember to seed rand with the current time by using srand. Without this, the sequence of random numbers would always be the same. As for the bitmap, we'll load that once and use it repeatedly for each array member. This is faster than loading the image multiple times for each individual object, and it also uses less system memory, which is always a good thing. Now that initialization has been taken care of, we can work out how to draw them. Again, because we're dealing with arrays, we'll want to use for loops to apply our instructions to multiple array members easily. This way, we can call drawObject for each of them with minimal effort. With our game objects declared and initialized to random locations around the screen, all we need is collision detection and movement. Collision detection is a key task in many games, and there are a variety of ways to perform it. The simplest is to calculate the distance between the locations of the two objects. Remember that Allegro draws images to the bottom right of the specified point, so our distances will all be relative to the top left corners of the objects. In previous examples, we've seen how to calculate the distance between 2 points. Let's add a couple of functions to GameObject.cpp and their prototypes to GameObject.h. Really, it's the same function twice. The first takes ints to calculate the distance, and the second takes game objects. Notice the minor differences between the two function bodies. Since GameObject is a structure with x and y coordinates as member variables, we need to access them through the structure, via the dot operator. The square root function requires us to include the math.h header file, so we should go to main.h and add it. Now in the update section of main, we can apply collision detection on the player and all the other objects in the game. We need 2 for loops, one for enemies and one for points. Just like array initialization, we can loop through every array member and apply the same code to multiple objects. In this case, we're calling the distance function from the if statement's condition. This is perfectly valid. The function gets called and will return a value, which will be compared against the rest of the condition. If the distance between the player and the various point objects is less than 10, then we increase the score by 1 and move the point object way off the screen, effectively removing it from the game. For the enemies, the process is the same. but instead of increasing score and moving the object away, we will end the main loop, thus ending the game. Except we can't end the loop. We set the condition for our loop to be true. To get out of this, we use the break command, but break ends the current loop. And now we're in another loop, one to cycle through each enemy. In this situation, we can't use break. We'll need to go back and use a boolean again. So before the while loop, we'll add bool quit equals false, and as the loop's condition, replace true with quit is equal to false. Now in our enemy collision detection loop, we'll set quit to be equal to true, thus ending the loop. Bear in mind that the break command we used when escape is pressed still works just fine. Break can get out of any loop, regardless of the loop's condition. Finally, we just need to move the enemies automatically. This can be done in Update very easily. Using the usual for loop to cycle through enemies, we simply increase their x and y values every frame. And that's it. We have the basics of a functional game. Here's something you might want to consider adding yourself. Currently, when the program runs, the enemies will start moving, but eventually move off the edge of the screen. How do you think we can change the program to make the enemies bounce off the walls and move in the opposite direction? We'll leave you with that thought and see you in the next video.